Hey, this is Jun here, and I'll be explaining about color and color perception. So, when we think about color, we think about the different types of color that we see on a regular basis, such as red, yellow, green, and blue. But color, in a way, is a form of light. And when we think of light, we think about what our eyes can see, but there's more to light than just what our eyes can see. In fact, if you take a look at the electromagnetic spectrum, which describes the entire range of light that exists, you'll see that there's more light that we cannot see than the ones we can see. In fact, the light that we can see is just a small part of the electromagnetic spectrum. The small portion you can see here, that is known as the visible light. And that is where color exists. As you can see here, there are 7 lights in the visible spectrum. Red, orange, yellow, blue, red, orange, yellow, green, blue, indigo, and violet. Indigo is not included in this picture, but it comes in between blue and violet. And all these lights have different wavelengths, which is precisely why we perceive red as being red and green as being green. And you can say that these colors are different because they have different wavelengths. And that tells us one thing: light is responsible for color. So, Newton proved this fact with his famous prism experiment, where he refracted white light into a prism and saw it disperse into 7 component colors, which are the colors we see in the visible light spectrum. But the lights are refracted at different angles, which tells us that they have different wavelengths and, as a result, different colors. You can see in this image how white light is refracted in and dispersed into 7 different colors with different wavelengths. And yeah, please don't mind the fact that I used the Pink Floyd album cover to describe this. And yeah, anyways, so one more thing I need to let you know beforehand is that color doesn't really exist in our lives. I mean, as much as it feels like it does exist, it doesn't. In fact, we are able to see and perceive color because they exist in our brains. So our eyes have 2 photoreceptors in its retina, the rods and cones, which respond to light. And I'm mainly going to focus on the cones since that is what allows us to see color. So there are 3 different types of cone-shaped cells. The long wavelength cones that best respond to the color red, indicated by L. The medium wavelength cones that best respond to the color green, indicated by M. And the short wavelength cones that best respond to the color blue, indicated by S. And because red, green, and blue are the only cones that are present in our eyes, they should be the only colors we see. Yet we all know that's not the case. I mean, over the course of our lives, we have seen millions of different colors. Well, how is that possible when we have only cones designed to perceive 3 different colors? Well, the answer is color mixing. Look, take a look. So we have the 3 colors red, green, and blue, and they mix with one another to form different colors. And that's how we see colors like, yellow, magenta, cyan, and all these other beautiful colors that we see every day. So, back to the main thing. How is it that we perceive all these different colors? Well, let me give you a simple example. Say you're looking at this apple. Now, unless something is wrong with your color vision, you will see the apple as red. Well, but why? I mean, why red and not yellow or not blue? Well, here's the reason. So, we're able to see an object's color because light is being reflected on them. Some lights might get absorbed by the object, and some might get reflected back to your eyes. And the wavelength of the light that is reflected is the color that you're going to see. So yeah, if you take a look at this apple, you see the light being, absorbed by the apple, and only red is the color that is reflected, and that is the color we see. And that's why we see the color of an apple as red. And yeah, that's pretty much the mechanism behind color perception. And that concludes my presentation of color and color perception. Hope you liked it.